Hello everyone, this is Mukesh Kumar Tiwari from LP Public School. Today we talk about for the ionic equilibrium of class 11th chemistry. You know very well that during the physical classes we already talked about for the most of the topics of ionic equilibrium, and I think one or two topics are remaining now. And the topics, the first one is the solubility product constant or solubility product. So today we talk about for the solubility product constant. Solubility product constant. So first of all, before talking about for the solubility product constant, first of all you have to know that what is the need for the study of this topic. You know very well that there are different kinds of the salts are known, and some of the salts are highly soluble in water and some of the salts are insoluble in water or strongly soluble in water. So you know that when we talk about for the solubility of a strongly soluble salt, so in case of strongly soluble salt, it will not completely break into its constituents ion, and there will be an equilibrium is formed between the undissociated molecule and its ion, and that is known as solubility equilibrium. And this solubility equilibrium is the special case for the strongly soluble salts. Clear? You know very well solubility equilibrium. Solubility equilibrium. In solubility equilibrium, suppose there is a salt like AgBr are given to you, and this AgBr breaks into its ion like Ag plus and Br minus. So here this AgBr is a strongly soluble salt, and it will not completely breaks into its constituents ion. Clear? And the process will be in equilibrium. And in case of salt, the equilibrium are established between the undissociated salt molecules and its ion are known as solubility equilibrium. Clear? So what is the need for the solubility product constant? Know that there are different types of strongly soluble salts are known, and if we have to compare the solubility of different strongly soluble salt, then there will be need of a constant or a value that is known as the solubility product constant. So with the help of solubility product constant value, we can easily compare the solubility of different salt in the water. Suppose if we talk about for the solubility of some compound like NaCl, KCl, LiCl, these are the salts are given to you, and you have to discuss that out of these three which have very high solubility in water. So first of all you have to go through the Fajans rule. You know very well what are the Fajans rule? Suppose when we consider this LiCl, so here chloride ion are the anion, here also the chloride ion are anion, and in KCl also chloride ion is the anion. And the cation is Li plus, here cation is Na plus, here cation is K plus. Clear? So out of these three salts, the chloride ion is common for all. So the anion will be Li plus, Na plus and K plus. Means cations are different. Clear? Out of these three cations, you see that the lithium ion have very small size. And when the cation size will be smaller, then the polarization will be very high. and when the polarization will be very high, then it will show covalent character. So in case of LiCl, NaCl and KCl, this LiCl have very high covalent character and the KCl have very high ionic character. Clear? So ionic character, the compound having covalent character will be covalent compound and it will very little bit soluble in the water, and this compound KCl have very high ionic character. That means it is highly soluble in water. So when we compare the solubility of these three, so out of these three, KCl have very high solubility in comparison to the NaCl, and NaCl have high solubility in water than the LiCl. So with the help of Poisson's rule, we can easily compare the solubility of the salt. In the same way, suppose AgCl, AgBr and AgI, these three salts, these all are the spirally soluble salts. Clear? These all are spirally soluble salt, and we have to compare the solubility of the salt in the water. So in the same way, we have to go through the cation and anion. Here the cation is Ag plus, anion is Cl minus. Here cation is Ag plus, anion is Br minus. Here cation is Ag plus and anion is I minus. So out of these three, the cation is common to all. Here the anion is Cl minus, Br minus and I minus. This is the chloride ion, bromide ion and iodide ion. So out of these three anions, iodide ion have very high or larger radii. So greater the radii of the anion, greater will be the polarization, and in this way greater will be the covalent character according to Poisson's rule. So when we compare the solubility of these three, so here AgI, that is silver iodide, have very high covalent character and AgCl have ionic character. So out of these three, AgCl will be very highly soluble in water as compared to the AgI, because here the covalent character is very high and here ionic character is very high. So in this way we can compare the solubility of some given salts. But suppose there are many miscellaneous types of the questions are given for the comparison of the solubilities of the salt. So we have to go through the solubility product constant. So let's start our topic is solubility product constant. Listen my notes very clearly, that is the solubility product constant is used for the comparing of the solubility of spirally soluble salt. Clear? This solubility product constant is denoted by KSP. KSP. Suppose a salt like AgBr are given to you, and this AgBr is break into Ag plus and Br minus. Here the equilibrium is established, and when we apply the law of equilibrium, then we get concentration of Ag plus into concentration of Br minus upon concentration of AgBr. Although here AgBr is very little bit soluble in the water, so after multiplying this value with the constant K, this will changes into the concentration of Ag plus and concentration of Br minus. And this is the constant, and after multiplying this factor to this constant, it will give a new constant like KSP. This is the solubility product constant of AgBr. So we can write here Ag plus, concentration of Ag plus and concentration of Br minus. This is the solubility product constant for AgBr. Clear? In the same way, we can also write the another example for the Ag2Cr4. This is the another sprangly soluble salts are given, and we have to write the solubility product constant value for this salt. In the same way, K is equal to concentration of Ag plus to the power 2, because here the 2 Ag plus are formed, the coefficient are 2, and here Cr4 2 minus upon Ag2 Cr4. After multiplying this factor with the constant like this, it will changes into the Ag plus to the power 2 into Cr2 minus, that is the bromate ion, and after this will be the solubility product constant of, this is the solubility product constant of silver bromate. So in this way we can find out the solubility product constant for any given sprangly soluble salt. Now we have to talk about for what are the relations between the solubility product constant and solubility. So let's start the relation between Ksp, that is the solubility product constant, and solubility for any given solubility divided by small s for any given sprangly soluble salt. Suppose we have to find out the relation between the solubility product constant between the solubility for the salt AgBr like this. So the same thing we have to do as the given here. Clear? And the solubility of this ion, that is the Ag plus and Br minus, will be small s mole per liter. So when we put the value of this Ag plus, like here, Ag plus ion, concentration of Ag plus is equal to small s mole per liter, and in the same way Br minus like a small s mole per liter. So Ksp will be the Ksp is equal to s into s, and here Ksp is equal to s square, or s is equal to under root Ksp, or s is equal to Ksp to the power 1 by 2. So these are the relations between the solubility product constant and solubility of the salt like AgBr. In the same way, we can also find out the relation between the solubility product constant and the solubility for a salt like this silver bromate. In the same way, we have to write the Ksp is equal to, here the concentration are given Ag plus to the power 2 and 2 mole are given. So we write here 2s to the power 2, because here the coefficient are also considered. So 2s to the power 2 into here s like this, and Ksp will be the 4s square into s, or Ksp is equal to 4s cube, or here s cube is equal to Ksp upon 4, or you can also write here s is equal to Ksp upon 4 to the power 1 by 3. So in this way we can write the relations between the solubility and solubility product constant for any given sprangly soluble salt. Now we talk about for the what are the application of this solubility product constant. So let's start. With the help of solubility product constant, we can easily compare the solubilities of the different salts. So first thing is that suppose more than 2 or 3 salts are given to you. First we have to go through the applications. What are the applications of this Ksp? The first application is that KSP value is directly proportional to the solubility of salt. What do you mean by this thing? That is, greater the value of KSP, greater will be the solubility of the salt. Suppose 3 or more than 3 like A, B, C and D. These 4 salts are given to you and their KSP value are also given. And you have to discuss about that out of these 4 which have very high solubility, then you can compare the KSP value for each given salt. So greater the value of KSP, greater will be the solubility of the salt. Clear? The second thing is that anionic product versus solubility product constant. This anionic product is denoted by Q. So we can also compare that when the precipitation will take place, when the solubility will be high in the sets of these two things. First thing is that when KSP value, when KSP is greater than Q, then solubility of salt or solubility of salt will be high. That means no precipitation takes place. In this case, the precipitation will not take place. Clear? The second thing is that when Q is greater than KSP, that is anionic product value is greater than the solubility product constant, then solubility of salt will be very low, that is precipitation of salt will take place. In this case, precipitation will take place. Clear? So we can compare the solubility as well as the precipitations. A lot of things are we compare with the solubility product constant. Clear? So I hope that you all are very efficient to learn this topic, that is the solubility product constant. And thank you for watching my video. And for the next topic, that is I will talk about for the buffer solution in my next video. So come for watching the buffer solution explanation in my next video. Thanks a lot.